Welcome to Graphing Quadratics number 4, where our objective for the day is to learn how to write an equation from standard form, which is the form that we are used to. So we're going to learn how to convert an equation from standard form into a new form, which is called vertex form. So there are different ways to write a quadratic equation, and we would use different ways for different purposes. So let's start off with standard form because that is what we are used to. Standard form is y equals ax squared plus bx plus c. And in this form, A is really important to us. What does A tell us? A tells us that it's either going to be a smile, which would be a minimum value, or it would be a frown if it's negative, which would give us a maximum value. So that's important stuff. And then our constant is the y-intercept. So I don't have to graph it to know where it's going to cross the y-axis. I can tell based on my constant value. So I can see some things. I can see if it's a smile or a frown. I can see the y-intercept, but what I can't see is the vertex. The vertex we have to do work for, and that is what we have done over the past 3 lessons, is find the vertex. However, in vertex form, which is y equals a times the quantity x minus h, square it, plus k. So in vertex form, I can actually see the vertex point just by looking at the equation. So h is the x value of the vertex, and k is the y value of the vertex. So just by looking at this form, I don't have any math to do. I can just write down what my vertex point, or where my vertex point is located. And we still have this a value, so I still know if it's going to be a smile or a frown. I still know whether it's going to be a minimum value or a maximum value. So the major difference between standard form and vertex form is in standard form, you can see the y-intercept, which is helpful in some situations. And in vertex form, you can see the vertex, which is helpful in different circumstances. Okay, so the thing that you need to be careful about in vertex form, where do I want to write this? I guess I'll write it over here. The thing that you need to be careful about is h. So h is written as a subtraction problem, and subtraction means the opposite. So when you are looking at h in any of your equations, h is always going to be the opposite of the way it looks. And that just takes some time to get used to. So because it's a subtraction problem in the formula, the subtraction means that h is going to be the opposite. So when I look at number 1, I can see the a, h, and k. A is this 1 out in front here. H is not -2, it's just a +2, it's opposite. And K is a +1. So A is 1, H is just 2, and K is a positive 1. So my vertex point, the vertex is located at H comma K. The vertex for this is located at positive 2, remember it's opposite, comma 1. By A being a positive tells me that it's going to smile, which means that the vertex is going to be on the bottom. So that means without graphing it, I know it's going to be a smile, and I know that that point is going to be located at 2 comma 1. So I should be able to do the range without even looking at the graph. I know that the lowest value is going to be the minimum value at 1, and then the smile is going to go up forever and ever and ever, which means infinity. And if you prefer an inequality, y's are going to have to be greater or equal to 1. We didn't have to do any work to get that vertex point. We don't have to do x equals negative b over 2a. So vertex form is actually really nice when you have to get the vertex. Okay, so number 2. There's A, there's H, and there's K. So the vertex point is positive 2, it's opposite, comma, negative 3. Because A is a negative, negative means frown, so that means that we have a maximum value. So it's going to be a frown, and that maximum value is going to be at 2 comma negative 3. So the range starting at the bottom, this frown is going to go down forever, negative infinity, and it's going to come all the way up to its maximum point located at negative 3. So y's have to be less than or equal to negative 3. Remember, you are pausing the video and you are working ahead of me and then playing the video and checking your answers. That doesn't look right. Well, what are we missing? Can I rewrite this in standard form? So A is the number out ahead, right? This thing squared minus 5. What would have to go with the x in order to square it and just have an x squared? Wouldn't that have to be a 0? So this is A, and that's H, and that is K. So x minus 0 actually just means an x squared. So the H on this one is missing. Okay, so the vertex is going to be 0 comma negative 5. A positive A means a smile means a minimum. So our graph is going to look a little something like that. The range, the smallest y value is negative 5, and then a smile is going to go up forever. So y values have to be greater or equal to a negative 5. Take a look at number 4. You've got A, H, and K. Who's K if it's missing? That would just be plus 0. So your vertex point is going to be opposite. So positive 3 comma 0. A value is positive. That means a smile. Smile means a minimum value. So that's going to be at 3 comma 0. The range is going to go as low as 0 and as high as infinity. So y values are greater or equal to 0. Number 5, I have A, H, and K. So the vertex point's going to be opposite. So positive 9 comma 3 A value is negative. Negative means a frown. Frown means a maximum point. So that's going to be at 9, 3. So this parabola, the frown, is going to go all the way down to negative infinity and all the way up as high as 3. That's the max value is 3. So y values have to be less than or equal to 3. Number 6. Number 6 looks a lot like number 3, doesn't it? All right, I'm going to rewrite it. So y equals a, well, isn't a just going to be a 1? X squared means x minus 0, square it, and then minus 2. So it's only an x squared because that's actually an x minus 0. So the vertex point is going to be at 0, negative 2. A value is 1. 1 is a smile. A smile is a minimum. And the y values are going to go all the way down to negative 2 and all the way up to positive infinity. So y's have to be greater or equal to a negative 2. All right, number 7 says, if the maximum point, so I'm thinking about what that looks like. A maximum point is occurring at 3, negative 4. So that means 3, negative 4, okay, we're looking like that. It is a maximum point, so I know that it's going to be a frown. And I know that this is h, k. Write a possible equation in vertex form that could model this parabola. How many roots are there? All right, so vertex form is this. A times x minus h, square it, plus k. So one possible equation might be a has to be negative because it's a frown. So pick a negative number. I don't know, negative 2. That's good. It just has to be negative. X, okay, that is a positive 3. So I have to do the opposite. So a positive 3 means x minus 3, square it, and then minus 4. Here is a possible equation. Could you have done negative 3? Yep. Could you have done just a negative 1? Yep. A negative 10? Yep. The point is that had to be negative because it's a frown. All right, and then how many roots are there? That means how many x-intercepts are there? Well, since it opens down, it frowns, it's never going to touch the x-axis. So that means that we have 0 roots. There are no x-intercepts. Okay, try this one on your own. Pause it and then do it. If the minimum value means it's going to be at its lowest, so it's a smile. So a smile is occurring at 0, negative 3. So we'll say about there, and it's going to be a smile. Write a possible equation in vertex form that could model this parabola. How many roots are there? Okay, so because it is a smile, I'm going to need a positive a value. How about a positive 3? All right, and then x minus 0, square it, minus 3. So if I want to clean that up a little bit, I don't need x minus 0. That's just going to be an x squared minus 3. Could that have been a 2 or a 10 or 100? Yes, absolutely. It needed to be a positive number. This is a possible solution we're looking for, so we were just looking for a positive number there. Maybe I should make a note of that. Here, you need a negative a value, and here you need a positive a value. Okay, so that is my possible equation. And then how many roots are there? Well, we know that this is going to smile and open up. That means that we are definitely going to pass through the x-axis at 2 different points, which means that there are 2 roots in this problem. I'm not concerned about where they are at this moment. I'm only concerned with how many are there, how many roots are there. All right, cool. So the last thing that we're going to talk about is this conversion process from standard form to vertex form. We are given standard form, I would say, most of the time. And sometimes it is a great benefit to us to take our standard form equation and to rewrite it into vertex form. So this process of converting from standard form to vertex form is called completing or complete the square. Ladies and gentlemen, if this were an honors math 2, there is an algebraic way that we can complete the square. Since this is not an honors class, I will not be doing that challenging algebraic conversion. I'm going to show you how we can use technology to accomplish the same thing. Okay, so please know that standard and vertex form are just 2 different ways that express the same function. It's the same equation, just written in 2 different styles. So every standard form equation can be written in vertex form. And likewise, every vertex form could be written in standard form. So it says, using your graphing calculator, match each equation in standard form with its equivalent in vertex form. So, okay, so what I'm going to do is I am going to thoughtfully figure out which 2 should go together, and then I'm going to graph them on Desmos. I'm actually going to Desmos, North Carolina. I'm going to go back to this. It was giving me problems in my last video, so I'm just going to open up a new version of this, and hopefully that fixes my problem. Okay, so looking at my matching, don't you feel like B should match up with H? Because this is the only frown, right? And this is the only frown. So I'm thinking that B and H should be the exact same equations. I'm not going to write them as f of x. I'm just going to use y equals. It's easier to type in. So I am doing B, which is negative x squared minus 12. I lied to you. I looked at the wrong one. Plus 6x, and then minus 5. And then I'm going to compare that to H, which is y equals negative parentheses x minus 3, square it, plus 4. So you can see that they have graphed on top of each other. Watch, if I click the red one and then I click the blue one, you can see the graphs changing colors. They are in fact the exact same graph. So that means that I can put those 2 together. Okay, so what else are you thinking? Are you thinking that maybe this one that has an A value of 2 would match up with this one that has an A value of 2? The one thing that never changes is A. So I would say that that is a safe bet. And I'm actually going to write that down. The thing that never changes between the forms is the A value. That never changes. Okay, so I'm testing C with F. All right, so C is going to be a 2x squared minus 12x plus 13. And F is going to be, F is going to be a 2x minus 3 squared, and that's going to be a minus 5. I have too many x's in there. Okay, so just double checking my equations. If I flip back and forth between the two, they are in fact the same thing. So that means that I can now put C with F. All right, so now we just need to make a decision and test A. So x squared plus 4x plus 4. And this is where you might want to jump ahead of me and kind of go with your gut. Is A going to be matched up with E or with G? Pause the video, punch it in, see what you come up with, see if your gut was correct. All right, so A is going to go with G. Okay, there, same thing. So if A goes with G, then that means that D is going to go with E. So the purpose of this was to show you that standard form and vertex form is just a different version of the exact same graphs. This is a test review question. So this was pulled off of a released NCFE, so your North Carolina final exam. This is one of the questions that used to be on the final exam. So it says that the equation, okay, I don't like the way that's written. Let's get that into standard form first. So that means that I'm going to have to add 12 on both sides. So 2x squared minus 5x plus 12 is in standard form. Okay, so I need to change this standard form somehow into this vertex form. So the nice thing about vertex form is you can see the vertex. So the vertex here is at P, comma, Q. If these are the same thing, then that means that their vertex should be the same. So if I know that P comma Q is the vertex, can't I just find the vertex of this and then that is the same thing? And I'm looking for the value of Q, which means I'm looking for the Y value. So I'm going to take this and I am going to plug that in. So it's going to be 2x squared minus 5x, what was it, plus 12. And there's my vertex. So by using Desmos, we figured out that the vertex here is 1.25, 8.875. If you don't like the fact that that's 3 decimals and you are not confident that that is an exact answer, I'm going to go to my table of values and I'm going to go to 1.25. So instead of using algebra to plug in, this is a shortcut. I'm going to go to my table of values and I'm going to plug in 1.25, which gives me exactly 8.875. So that is my Q value. So Q is equal to 8.875. Hey, Ms. Smith, what if that needed to be in fraction form? Well, if I punch in 8.875, my little fraction box pops up and I can, convert that into a fraction. So it's either 8.875, or you could say 71/8. Both of those are correct. Using technology to help make this a painless process. All right, so last thing here is we need to do some converting. So the thing that never changes is the A value. So we need to figure out what the A value is first, because it is going to be the same A value when we put it in vertex form. So what we need to do when we are given standard form, so let me kind of draw this out for you. When we are given standard form, we are going to find the vertex. How can we do that? Well, we can use algebra, we can use Desmos, we can use our graphing calculator. And then once we find the vertex, we can go ahead and we can write it in vertex form. So I've already done my option 1 and option 2. Actually, I have 3 options, right? I can use algebra or Desmos or a calculator in order to find the vertex point. Remember, x equals opposite of b over 2a to help us out with that. Once I get vertex form, then I write vertex form by replacing the a, h, and k with the correct values, of course. Okay, so step number 1, the thing that never changes is a. So that means that my a value for this problem is 3. Step number 2, I want to find the vertex of this thing. So I'm just going to hop right over here and do y equals, try again, y equals 3x squared plus 6x minus 4. And I'm going to grab my vertex, which is located at -1, -7. And then I'm going to use my a, h, and k values. So I know that this is h, which is, I'm actually not going to do that. That's h, and that's k. So my last step is to write a times x minus h square it plus k. So here's the final step. I take a and I plug it in. This is going to be x, and then it's opposite of -1. So plus 1, square it, and then k, which is -7. That's it. That is your vertex form. Now remember, this is not an honors class. This is not the algebraic way that I complete the square. This is using my technology tools in order to complete the square. Since this is a new process, I definitely want to check to make sure that my equation in vertex form is the same equation as standard form. So very quickly, I'm going to go y equals 3 parentheses x plus 1, square it, and then -7. So those two things should be the exact same thing. If you say forgot to do the opposite of h, you will see that that does not give you the same equation. So please make sure that you're checking your answers. It took me literally 15 seconds to type that in to make sure that we had the exact same thing. All right, last one. So I am going to step number 1, write down a because it never changes. A is -1. Step number 2, I am going to find the vertex. So that's going to be y equals -x oops, squared minus 4x plus 7. And the vertex, I'm going to grab it right there, is -2, 11. So that means that that's the h and that's the k. So I'm going to write this in vertex form. So A is a -1. H is opposite, so I'm going to write x plus 2, square it, and then plus 11. So that is my equation written in vertex form. And of course, I'm just going to take 15 seconds to check myself. So y equals -1 x plus 2, square it, plus 11. And check it out. They are, in fact, the exact same graph.